Hi, this is my showcase of using the DeepQ network agent. After some minor fixes, I finally managed to get to learn. So I'll go ahead and just run it. So as you can see, the DKN agent works pretty well. I would say it is able to avoid obstacle well, but sometimes it still collide heads-on with obstacle in front of it. But overall, it manages to chase the evader decently well. So right now, like I changed the action space a little bit. So right now it can only choose 0.2 speed. So I limit it to only using one speed, so it can focus on learning the turns. But I think for harder maps, I think adding a second speed of 0.1 will help it to robustly maneuver itself across difficult maps a lot better. I can go ahead and show you the convergence graph. Hold on. Yep. So this is the. Is there a way for me to zoom in? Yes. So as you can see, there's clear convergence here as the accumulated rewards converge around this line, like plateau here. The robot chooses to turn left a lot more dominantly when the opponent is to the left, and also learns to turn right a lot more when the opponent is to the right. But interestingly, when the opponent is right in front of it, it chooses not to go straight, but rather turns more often. So this is weird because because it seems like it's still chasing the opponent here when the opponent is still going straight to chase the opponent here when the opponent is right in front. So I'm guessing it's just some minor error in my plotting code. Yep. And overall, it managed to, after a while of training, it managed to minimize the distance between itself and the other agents pretty well, and the evader pretty well. So here you go. So this plot is the average Q value of all actions across the training episode. So on its own, it doesn't really have a lot of meanings. It just tells you like the average expected what is it? The average expected rewards the agents expects to have at, like every training episode. So overall, it learns to kind of increase its rewards over time. But this average key value doesn't really have much interpretation. It's just there to show the stability of our learning algorithms. And so does the loss of our Q network prediction. So overall, it stabilized a little bit. So the prediction gets kind of closer to the real target values. And as you can see here, every test phase, now the DeepQ network agent is surprisingly a lot more stable compared to the Q learning agent, because you can see that its performance stay roughly the same across different test phase. While for the Q learning agent, it was a lot more volatile. Yep, I guess this is it for my showcase today. Thank you so much for watching, and have a good day.